lowercase.
Okay. 5.1, rational numbers. Okay, so here is like a visual aid of what rational numbers look like. So I have this whole overcompassing term. The overcompassing term is rational numbers. Inside of it, there are integers, and inside of integers, there are whole numbers. Okay, so a rational number includes integers and whole numbers, but whole numbers do not necessarily include integers. And they do not necessarily include rational numbers. What?
Do you know how to do it?
Yes. Turn around. Rational numbers are an overcompassing term for like all types of numbers that we deal with. Okay? Within rational numbers, there are integers. Within integers, there are whole numbers. So whole numbers is like the smallest thing we're talking about right now. Integers include whole numbers, but whole numbers are not necessarily integers. Like, and then it keeps going back like a magnifying glass. Rational numbers are numbers that are written as a quotient of two integers. What does quotient mean? Divide. So when I'm asking for you to write this in terms of a rational number, that means you have to show it to me in terms of division. Okay? In terms of division. So the first 4 examples actually state that. They say show these whole numbers. Okay, show the whole number is rational, but writing it as a quotient of 2 integers. How would you write 7 as a quotient of 2 integers? By what?
7 and 1.
Yeah, 7 and 1. So I would say 7 over 1. Okay?
Let's go.
Because when I'm writing a whole number as a quotient as integers, basically I'm turning it into an improper fraction. Okay.
Say that again.
Basically you're turning
I
it
remember
into an
that.
improper fraction.
I remember. So that's
We did this
So
last
how would
year.
you do negative 10?
5 and 2.
Negative
negative
10 over 1.
I knew
No.
that.
No, don't we?
Yeah.
have
No,
to-
1 over
negative
negative. 1 over
10.
10. No, negative 10 over 1. Yeah. 1 over. Wait. Is it 1 over 10 or
There you
negative
go.
10 over 1?
Come
No.
on.
If I have 1 over 10, I have 1/10. That's not an improper fraction. So you're right. I want 10, and I'm going to put it over negative 1. And
Oh.
negative is going to go on the bottom in this case.
Negative always on bottom.
Well,
Or-
because well, sure. Yes, let's just go with that.
Okay.
Okay. How would you write 5 3/4? How would you write 5 3/4? How do you change 5 3/4 to an improper fraction? What?
You would do like 23
Mm-hmm.
over 4.
Beautiful. So the way I remember it is this is the easiest way. You take 5 and multiply it by the denominator and then add the numerator to it. Okay. How would you do negative 3 1/2?
I know what you would do.
What?
You would do.
I'm changing them to.
I know what to do. I know what to do.
Okay, what? E?
The answer would be 7 over negative 1.
7.
No, 7 over negative 2.
Yes, 7 over negative 2. Okay.
Quarters.
So when you yes, Emma.
I'm still so lost how you got like 20.
Guys, stop. I'm changing them into improper fractions. You literally take whatever the whole number is, multiply it by the denominator, add the numerator. 5 times 4 is 20. 20 plus 3 is 23. 23/4.
And then you divide it by
Yes, because I'm changing it to an improper fraction. If I divide 23 by 4, I get 5 3/4. If you do long.
I never.
Okay.
Okay.
I always play that game.
So I'm just changing it back to an improper fraction. Focus.
Well, whatever's on top will always be positive.
No. Yes, I said just make that positive, make the denominator
So
negative.
you got 7 over negative 2 becomes
Because you do 3 times 2, which is
6.
plus
Negative
1,
Oh,
7 over negative 2.
okay.
Okay?
Yeah.
Okay. Terminating decimal. We like terminating decimals. And I'm going to tell you why you like terminating decimals. A terminating decimal is when you divide something and its final remainder is 0. Do you like when things come out even?
Yes.
Yeah.
Yes. That's what a terminating decimal is. It's when it comes out to 0. Okay? A repeating decimal is a digit or a number of digits that repeat. So like you can have a repeating decimal like 2.33333333. Or I could have a decimal that says 2.123123123 and it repeats in that form.
I have no idea what we're doing. I know you got 23.
Cause you times 4, then you add 3.
Okay,
She told us how she did it.
now we're awake.
Yeah, I was
So when I'm dealing with terminating decimals, if something's a terminating decimal, that means I get 0 as my final answer. Okay, like 0 is the last thing. It goes in even. It's beautiful. When I have a repeating decimal, that's when I gotta start working on things. How would you change? How would you change a decimal, a fraction to a decimal? What would you do? And no, what?
for me.
Yeah.
3, 6.
Well, I asked how would you change it, not what is it.
Well, 1/8 is 0.12, and then you multiply that times 3.
Wow.
Okay, here's what we're gonna do. Here's how you're going to do this because you're not going to use a calculator and you're going to show me work. Do you understand? So the answer is not let's plug it into our calculator. The answer is this. I'm going to take 3 on top, okay? And I'm going to say, technically this is saying 8 goes into 3, correct?
Yeah.
3 divided by 8. So I'm going to set it up that way. I'm going to say 3, and I'm going to put decimals with it so that I can divide it by 8. Okay? Now, can 8 go into 3?
No.
So I put a 0. You remember long division?
Yeah.
How many times does 8 go into 30?
3.
Okay, what's 3 times 8?
24.
And what's 30 minus 24?
6.
Then I bring down the 0. How many times does 8 go into 60?
7.
56.
Okay.
No, say yes.
56.
And you get 56, and you get minus
4.
and I bring down this
5.
5. And look, it stops because it's even, correct?
Yeah.
So this is my answer.
Yeah,
Well, that's how I change the fraction to a decimal. I want to see long division on your paper.
Why?
Okay, wait, Josh first.
How do you
Josh's
know what to
hand.
put your-
Wait, Josh's hands first. What, Josh?
So every time you do it, do you have to have 3 zeros behind it?
Not necessarily. I kind of cheated because I know that it would even out to be nice. Here's what you're going to do. You're going to add as many zeros as you need until you either get to a spot where you get 0 here, or where you get to a spot where this starts to repeat. Like if it had said 3, 7, 5, 3, then I can stop.
So the least amount you should have is at least 3.0.
What?
Or like 0. Like you should at least have 1 0 if we do.
We should at least have 1 0, yes. Okay. What's your question, Jason?
No.
Jacob, do you have a question?
So for the whole thing, to get the fraction to this one, you just divide the bottom, the denominator by the numerator.
You divide the numerator by the denominator.
Wait, do you automatically put the decimal point right after?
Oh, yes, but I'm dividing the numerator by the denominator. I'm taking this into this.
Okay.
You just worded it wrong. It's okay.
Do you always put the decimal point after the
Yes. Okay. Now, how would I set up 5/11ths? What would I do? Stop. Back table that's making unnecessary noises. Your card's gonna get necessarily marked soon. Okay. How do I do 5/11ths? Okay. What, Josh?
You would do 11 will go on the outside,
Mm-hmm.
and then you would do 5.0.
Okay. I'm gonna just put a couple there until I know.
Yes.
Does 11 go into 5?
No.
Yes.
No. Can 11 go into 50?
Yes.
How many times?
4, baby.
So you get 44. What's 50 minus 44?
6.
And how many times does 11 go into 60?
5 times.
Giving you.
55.
So I need to add another 0. Stop. So you get 5.
It's gonna be repeated.
Well, maybe.
Oh yeah.
How many times does 11 go into 50?
4.
Okay, you say it's going to be repeated
So
right
now
now.
you gotta put the line thingy over top of
Beautiful. Okay.
Yeah.
So then I'm going to get this, and you get
That's repeated.
yes, it keeps repeating, correct?
Yeah.
Okay. So you are correct. I'm going to just take this portion right here, okay, and I'm going to write my answer as this 0.45 with a bar over there because that it starts to repeat after that 5. Yes,
How do
Emma.
you know that there's another 5 after?
Because watch, if I would put another 0, I would get 6, and I would get 0, and I would do 5 again, and get 55. And then I can see that there's a pattern going on. Do you get what I'm saying?
Yeah.
Okay, and so then you're going to list your decimal as 0.45 with a bar over it. That represents that it just continues to repeat. Okay, so I can leave it in that form. So, on your homework, when it says write this as a decimal, if you do not show me long division on your page, I'm not counting it as correct. Do not plug it into your calculator.
I would put in my calculator for number two.
You can check it that way, but I better see long division.
Yeah, sure, we can do that. Yeah, yeah. we can do that.
Correct long division too.
Yeah.
I will go through and check. Okay, couple more problems and then we'll be done. Of the 50 mammal species found in Canyonlands National Park, 20 species belong to the order of the rodent, okay? Of the 54 mammal species found in Badlands National Park, 24 belong to the rodent category. In which park is the fraction of mammal species belonging to rodent greater? What do I need to do?
You do.
Carter, what do I need to do?
Do you 20 over 50 for the one part?
Yeah, for the canyons.
Canyonlands, and then 24 over 54.
Okay.
For the Badlands National Park.
24 over.
Oh. Yeah.
Wait a second.
54 over 24. 24
Want me to-
over 24 over 54.
24 over 54. Wait a second. I feel like I missed something. This one's not 54. This one's what?
Oh no, yeah, that's right. I'm sorry, that's 50.
This is 50. Okay. So now I have two fractions. How do I know which one's greater?
You have to divide them.
You have to make them the same denominator, or I can turn them into what?
Decimals.
Decimals. Either way. Okay.
Would either way, like either way be right?
Either way would be right, unless they specify. Boys, stop. Unless they specify, either way's right. So if I turn this into a decimal, okay, I have 50 into 20. I'm just giving us a little extra practice on this. So 50 cannot go into 20, right? But 50 goes into 200 how many times? 4. And that comes out even, so that's beautiful. So this one is 0.4. Does 54 does not go into 24, right?
No.
How many times does it go into 240?
Carter.
3, 4.
50, 100, 150, 200.
I'm gonna say that
Four
right.
times.
4 times, yeah.
4 times 4 is what?
16.
16. And then 4 times 5 is 20, right? So that's what you get.
Yeah.
And then you get this. Nope, I lied.
She's doing what Carter does.
I believe it's going to be a repeat.
I believe it.
Is it a repeat of this
It is, but watch this. So 240 minus 2160 is 340, right? 3-4.
No, it should be 2. It should be 2. You take 1 away from the
You're right. It is 2. I'm right. You're right. And then I bring down a 0. How many times does 54 go in there? 4. So yes, it is a repeating decimal, which means which is greater, 0.4 or 0.44 repeated?
0.4.
0.4. Repeat it.
Yes. So this is my answer or my solution. Okay. Last 2 things. Okay. Write a decimal as a fraction. How do I turn a decimal into a fraction? 0.7 should be easy. What do you do?
What I do?
Yeah, what do you do?
And I in the 10th place.
Yes, the 10th place.
So it's 7 over 10.
So it's 7 over 10. Beautiful. What about negative 3.05?
That's like 3 and then 5 over 100.
Which you can reduce down to 1.
Right, which I could reduce down to 1 over 20.
Thank you.
Okay.
But wait, can you not have negative fraction?
Can you not have a negative fraction? What do you mean? I can have negatives. Yes, you must reduce, reuse, recycle.
reduce, reuse, recycle. What?
Yeah. Reduce in math, always, okay?
So,
So they'll want your answer to be -3 and 1 5. Okay, last thing, and here, I have it already written out in steps, and I need you to pay attention to this, because this is where you're gonna get confused. Okay? Is to write this decimal,
Whoa.
0.93 as a fraction. What do I know about 0.93 with that bar over it? It's repeating. It's repeating. If I want to change a repeating decimal into a fraction, I have to do some algebra behind it with multiplying by 100 and some crazy stuff. Okay? I'm going to say, hey, let me represent 0.93 as x. X equals 0.93 repeated. Okay? You're going to start by multiplying both sides by 100. So I'm going to get 100x equals 93.93. Because I multiply both sides by 100. Okay. Multiply 0.93 by 100. Okay? If you take 0.93, guys, I'm not going to help you on this if you're not going to focus.
I'm focused.
Take 0.93, multiply it by 100, because remember it's a repeating decimal. Okay?
That is 90, right?
So, if you take 0.93, multiply it by 100, you get 93. I want that repeating decimal still there, okay? Because I want to show that I still have a decimal place going on. So if I took 0.9393 and multiply it by 100, I get 93.93. Okay? So I get 100x equals 93.93. Now, what you do from there is you subtract this equation from this equation. What is 100x minus 1x?
99x.
99x. What is 93.93 minus 0.93? 93. So I end up getting 99x equals 93. How do you solve from there?
You divide by 99.
Divide by 99. What's 93 over 99 reduced to?
You divide by, what you divide by?
Yeah, I know. 31 over 33, right? Because 3 goes into 9 and 3 and 9. You're confused because your mouth doesn't shut.
That might be true.
Mine doesn't
We don't know that.
Okay? So listen, on page, write this down.
Okay.
On page 221, it is example 5 that is written out. It has verbal instructions. It has written instructions out like this too. So you can reference back to it and set your problems up the same way every time until you get used to it. It's something you have to memorize. It's like a formula you have to memorize.
You said 225?
Page 221,
no.
example 5.
What is that?